Okay, so in question 5, this is sort of on displacement, but also sort of on vector mathematics and thinking about summing vectors by components, so vectors in 2 dimensions. So we've got a displacement of a flock of geese of 5 kilometers directly east, and then 4 kilometers 4 degrees south of west. And we're trying to figure out the displacement, magnitude of the displacement from the Sunset Park to the university. So I'll start up here in the top right. This is question 5. So we've got 5 kilometers this way, and then we've got this 4 kilometers this direction. And what we're trying to determine is the size of the sort of the sum of these 2 vectors. So this is what we want to determine. So I decompose the 4 kilometer vector into its x and y components, or basically its west and its south components. So this is 40 degrees. So let me say I'll call this vector A, and I'll call this vector B. So B x, and sort of the x or the west direction is going to be 4 kms times the cosine of 40, and that's about 3.06 kilometers to the sort of west, this direction to the left. And then by is 4 kilometers times the sine of 40, so I'm trying to find the opposite side, and that works out to be 2.57 kms. That's sort of south. So we've got a 5 km east and 3.06 kilometers west. So they're in the opposite direction, so I would subtract the 3.06 from the 5. 5 is greater than the 3.06, so the net displacement in the x direction is definitely to the east. That should hopefully make sense. Of this size of this black dotted line is basically 5 is like 1.94 km, which you get from 5 minus the 3.06. And there's no y component of A, there's only a y component of B, so the y component of the net displacement is equal to the y component of B's vector. So 2.57 kms. And then to find the magnitude, I would do a Pythagorean sum. So let's call this vector C. So the magnitude of vector C would be equal to the square root of 1.94 squared plus 2.57 squared, both in kms, and that gives the magnitude of 3.2 kilometers. Okay. So yeah, so basically a vector addition question in the context of sort of displacement is basically what that's the underlying concepts of question 5. Okay, I'll follow up next with question 6.